So we're talking about the proof of the Pythagorean theorem. We know that the Pythagorean theorem states that c squared is equal to a squared plus b squared. And we have our triangle. That's c and that's a. Now we're going to prove it. We want to figure out why is it that c squared is equal to a squared plus b squared. And there has to be a reason as to why. All right, so we're going to start out with, say I have a line, right? And I'm going to split this line into two parts. I'm going to say this is B and this is A, right? If I wanted to find the full length of this line, what would I do to find the full length of this line? In order to find the full length of it, I would have to do a thing, A plus B, right? A plus B would give me the full thing. Now, what if I went ahead and I made this into a square, right? And then I made the same marks on all of it. So I'm still gonna put that there. And then B, A, B, A, B, A. So in order to find the full length around the whole thing, I would have to do A plus B, right? A plus B is this whole length, A plus B is that length and that length. How do I find, I'm going to show you two things. What if I connect these lines? I'm going to go ahead and connect these lines. What if I connect them? So I make from this line to this line, that's one. This line to this line, that's two. This line to this line. These are supposed to be straight lines. Okay. And then say I call the inside parts C. 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 So now I have a square on the outside and I have a square on the inside. All right. So what if I want to find the area? Let's find the area of the outer square. How do I find the area of a square? Do you remember? In this case, find the area of the square would be length times width, or in this case, length times length. Since in a square, all the length are the same. The length, though, is A plus B, right? And then I have to multiply that by A plus B. And then if I'm going to solve this, like we normally would, we do the distributive property. Do you remember that? This times that, this times that. But then since it's two terms, you have to do it for both of them. So then when you work that out, you end up with A squared plus 2AB plus B squared. Now, there's another way we could find the area of this square as well. The other way, put it down here, area of square, part 2. In order to do that, so if we look at this the square, we realize that if we want to find the area of this square instead of doing it the first way we did, another thing we could do, we could break these up in triangles. Do you realize that there's a triangle right here in the top left, a triangle in the top right? All these triangles are equal to the same because they have height B and length A. They all have the same height and all have the same base. All right, so in order to find the area of this triangle, we're gonna have to find, not triangle, the area for this big square, we're gonna have to find the area of the inside triangle. So the area of that inside triangle is c squared, because it's gonna be c times c. I keep saying triangle. The area of the big square, we're gonna have to find the area of the small square first and the triangles. All right, so the area of the small square is c squared, because it's c times c would give me the area of this inside square right here. Now I have to find the area of these triangle. The area of a triangle, I'm gonna have to add that. The area of a triangle is half base times height, right? So half, the base is A and the height is B. So half AB. And there are 4 triangles, so I'm gonna have to multiply this by 4. Now when I solve this out, c squared plus half of 4 is 2, so 2ab. So this is another way we could do to solve what the area of the big square is, all right? Now, since these two are equal to the same, this is the top one is the area of the square, the outer square, and the bottom one is also the area of the big square. So I could equal them out. So I could do a squared, I could say, let's use this color, c squared plus 2ab is equal to a squared plus 2ab plus b squared, right? Now I could group my like terms, and the only thing that I see groups that are similar is 2ab. So if I minus 2ab from this side, I have to do it on this side as well, which leaves me with c squared is equal to a squared plus b squared. And there you have it. That's what a proof is, where you go through and you try and figure out why is it that c squared is equal to a squared plus b squared.